You know that magnet on your fridge and the electricity powering your screen right now? They seem like they're from completely different worlds, right? Well, it turns out they are deeply, powerfully connected. So today, let's dive into this incredible, invisible force that literally shapes our world. So, what is the big secret? How on earth does a simple flow of electricity start acting just like a magnet? That's the main question we're going to unravel in this explainer. And trust me, the answer is way cooler than you might think. And the craziest part? This fundamental law of physics wasn't figured out in some high-tech lab with a grand experiment. Nope, it was a complete fluke, a happy accident that happened in the middle of a university lecture. And that one moment changed everything. All right, so here's our game plan. We'll start with that accidental discovery, and then we'll figure out how to map what a magnetic field actually is. From there, we'll see exactly how electricity creates its own hidden magnetism, how we can actually harness that force, and finally, where you can find this stuff working all around you. Okay, first things first. Let's head back in time to that pivotal moment in 1820. So picture this. A Danish scientist, Hans Christian Oersted, is giving a lecture. He's got a basic electric circuit set up, and nearby, on the table, there just happens to be a compass. He flicks the switch to turn the circuit on, and the compass needle jumps. He turns it off, and it goes right back. That little twitch was everything. It was the first solid proof that electricity and magnetism weren't separate things at all. They were two sides of the same coin. But hold on. Before we can really get how electricity makes a magnetic field, we kind of have to understand what a magnetic field even is. So how in the world do you map out a force that's completely invisible? You know, the easiest way to think about it is like an invisible bubble of influence all around a magnet. It's the zone where its power can be felt, kind of like a magnet's personal space, you know? Get too close and you'll feel the pull. Right, that's the real challenge. If you can't see it, how do you know what it looks like? Well, turns out there's a beautifully simple, almost magical old-school experiment that lets us do exactly that. And the solution is surprisingly low-tech. All you need is a regular bar magnet, a piece of paper, and some fine iron filings. You just sprinkle the filings all around, give the paper a little tap, and that's when the invisible suddenly appears. And look at that! The iron filings instantly snap into this incredible, elegant pattern. Each tiny speck of iron is basically acting like a mini compass, lining itself up perfectly along these unseen pathways of force. These pathways are what we call magnetic field lines. Now, these lines, they have to follow a few very strict rules. They always flow out of the North Pole and loop back into the South Pole. They always form these perfect closed curves. And see where the lines are all bunched up together? That's where the field is the strongest. And probably the most important rule, two lines can never, ever cross each other. It's just not allowed in physics. Okay, so now we know what a normal magnetic field looks like. Let's get back to Oersted's discovery. What kind of field does a plain old electric current create? Well, if we do that same iron filing trick, but this time with a straight wire carrying a current, the pattern is completely different. Check it out. Instead of looping from one pole to another, the magnetic field organizes itself into these perfect concentric circles around the wire. This is the unique magnetic fingerprint of electricity. So how do you know which way the circles are spinning? Clockwise or counterclockwise? Well, there's a really handy trick called the right-hand thumb rule. You can even do it right now. Just take your right hand, point your thumb in the direction the current is flowing, and the way your fingers naturally curl, that's the exact direction of the magnetic field. Super simple. A magnetic field around one little wire is cool, but it's not very strong. So how do we take this effect and really ramp it up to do some serious work? The solution is actually pretty genius. Instead of one straight wire, what if we wrap it into a tight coil, kind of like a spring? Each one of those loops creates its own little circular magnetic field, and when you stack them all together, those fields combine and get super strong. This special coil has a name. It's called a solenoid. And here is where it gets really, really cool. When you pass a current through that solenoid, the magnetic field it creates is, well, it's almost identical to the field of a regular old bar magnet. You've basically built a magnet just by coiling up some wire and running electricity through it. And to make it even more powerful, we can stick a piece of iron inside the coil. Now, what we have is an electromagnet. And here's the absolute game changer. Unlike a permanent magnet, this one has an off switch. You control the current, you control the magnet. It's magnetism on demand. So we know a current creates a field, But what happens when you take that current-carrying wire and you place it inside the field of a different magnet? Well, the two fields interact. They push and pull on each other, and the wire actually experiences a real physical push, a force. And yup, you guessed it, there's another handy rule for this one. It's called Fleming's left-hand rule. It's kind of like a secret handshake with physics. Just point your forefinger in the direction of the magnetic field, your middle finger in the direction of the current, and your thumb will automatically point in the direction of the resulting force or motion. This one interaction, this force, is the principle behind every single electric motor on Earth. Okay, so we've gone all the way from a twitching compass needle to coils and invisible forces. But why does any of this actually matter to you? It matters because this one single principle, electromagnetism, is the engine of our modern lives. It's what spins every electric motor, from your blender to an electric car. It's how loudspeakers and microphones work. It's even at the heart of advanced medical imaging like MRIs. And what's really mind-blowing is that this isn't just happening in machines. It's happening inside you, right now. The tiny electrical currents traveling through your nerves and your heart create their own tiny magnetic fields. And doctors can actually measure the fields around your heart and brain to diagnose certain conditions. So we've spent this whole explainer on Oersted's amazing discovery, how electricity can create a magnetic effect. But it leaves us with one last really big question, doesn't it? Does it work the other way around? Can a magnet be used to create electricity? Well, that is a story for another time.